this video, we're going to look at the Module 9 R code. So before we get started, we want to make sure that we have the files that we need. So the first one you should have is this Module 9 R file that has the script with the code in it. You'll also, as always, want to make sure that you've got the code book handy for the BFRSS. And then finally, you'll want to make sure you know where on your computer you have your state-specific date and probably not date, but data. And to follow along with this video, you'll want to make sure you know where the Kentucky data set is that we created in Module 6. So, as always, the first thing I'm going to do is I'm going to set my working directory. This tells R where all of the files I'm going to be using are. And so I've got this line of code to do that. The other way that you can do this is to click on the Files button right here. Then you'll click on these three horizontal dots. This is going to open up all of the folders on your computer, and you'll want to navigate to the folder where you have the files stored. Now this is only going to show the folders. It won't show any of the individual files, so just keep that in mind. And so you'll navigate to where that folder is. So that's what I'm doing now. I'm going to click OK, and that folder will open up in this window. And then you just want to double check in this window that you do see the data set. So I see the data set here. And then you can click on More, Set as Working Directory, and it will copy that code for you down here. And so notice that this code is the same that I have here. Since I already ran it and it appears down here, I don't need to run it again, but if you wanted to, you could. Alright, next thing I'm going to do is read in the data set. Make sure you have the name of the data set as well as .csv afterwards and header equals true. And then you can also use the view function to view the data set. Remember, the data sets are pretty big, and depending on the speed of your computer, that might take a moment. So I would not view the data set, but one thing you do want to make sure is that up here you see the correct number of observations and the correct number of variables. So just as a reminder, remember that everyone's data set will have 275 variables, but some of those variables will be all missing data. The reason for this is the BRFSS asks, those 275 or has 275 variables that go along with the survey. Some of the questions on that survey are part of the core, and some of them are part of the optional modules. So if your state did not participate in one of the optional modules, you will still have that variable name in your data set, but all of the data will be missing. So always keep that in mind. So the first thing we're going to do is we're going to see how to create a contingency table. So the first thing to do when creating a contingency table is to decide on the two categorical variables that you want to compare to one another. So in this case, I'm going to compare education level, which we saw previously, and this variable, it stands for imputed race. So one thing to keep in mind is in the BRFSS, some of the data set names, some of the variable names start with an underscore. R will automatically place an X in front of those. So to call this variable, I have to put an X in front of it in R. Those people that are using SAS don't have to do this extra step. So the very first thing I'm going to do is I'm going to see if there's any missing values for either of these variables. So I run this. I notice these are both 0 for the Kentucky data set. So if these weren't 0, I would want to make sure to maybe put myself a comment in here and record how many missing variables there were. So for mine, I'm going to put no missing values for EDCUA, EDUCA, and the race variable. Now, if you find that the number of missing values here is equal to the number of observations, that's a pretty big hint that that question wasn't included in one of the optional modules your state opted in because all the values are missing. Now, to create a contingency table, we could do one of two things. I'm going to copy some code here. So we could just run the table function like we have previously, and you'll notice that I've given this function two different arguments separated by this comma. The first one is the name of the data set, $, and then the education variable name. The second argument is the name of the data set, $, name of the second variable. So what I'm going to do is compare the education variable from the Kentucky data set to the race variable from the Kentucky data set. And if I run these, the table appears down below. Now remember that in the data set, all of the values for the variables are coded as numbers. So for example, if we bring our code book over and we look for the race variable, we can see what these different values represent. So here, since I called the race variable, the education variable first, education is going to be listed along the rows, and since we called the race variable second, race is going to be along the columns. So for example, this column right here represents all the people who've responded white, non-Hispanic. The second one is black, non-Hispanic. The third one is Asian, non-Hispanic, and so on. The other thing that we can do is we could assign this table to be an object, and we've done this before with frequency tables. So to do that, I still have the line of code that creates the table, and then I have what is called the assignment operator, and you can either use the arrow or an equal sign here. And then I have what I want to name the table, and you can make this anything you want. So since this is a table comparing education and race, I've called it ed_RA_table. And notice once we run that, the table did not appear down here, but we do see that it's now listed up here. So it's now something that we can work with. So one thing that we might want to do is add rows and columns to the table to make it easier to read. So to do this, there are two functions. There is the row names function and the column names function. So for the row names function, what I do is inside the parentheses, I give the name of the table that I just created, and then I create what's called a vector of labels, and you've done this before for education. So notice we have the C and then parentheses. So what this is going to do is it's going to combine all the different pieces together. So since these are all what we call characters or their names, we put them in quotations. And so what I've done here is I've given all of the levels for education in order. Now you want to be careful because the first thing to do is to look at the code book and see what those levels are. But if in your data set education is missing some of these, you'll need to leave those off. So that's why it's important to look at this table first without the labels to make sure that you really do have all of the potential responses in your data set. Otherwise, you'll need to leave off some of those labels. So here I'm going to name the rows of the table based on education, and I'm going to name the columns based on race. And so you'll notice I've done the same thing here with race, and I have used the code book to do that. Now, one thing to notice is here in the code book, if we use the full value label, that full value label is pretty long. So the first one, for example, would be white non-Hispanic. The second one, black non-Hispanic. Well, if we look through here, the values 1, 2, 3, 4, and 6 all include non-Hispanic, and of course 5, which is Hispanic, does not include non-Hispanic. So what I can do to shorten these labels is I'm going to leave the non-Hispanic off. But since I've left that information off, I would include probably a footer on this table that says, you know, something to the effect that all categories also included non-Hispanic, and make it clear. So you might give an example. So for example, white was non-white, non-Hispanic in the data set. So something that lets the reader know that you've left that label off. And the reason we probably don't want the whole label is when we go to make our bar charts and our tables, those labels are going to be incredibly long. So we want to make them shorter if we can. All right, so now running that column names row line. And now we can look at our table. So I'm just going to call the name of the table. I'm going to run this and it'll appear down here. And notice this is now much easier for us to read. We can see looking at this contingency table, all of our columns are labeled and all of our rows are labeled. Now these give us our frequencies. So in my data set, for the Kentucky data set, there were 2 people who identified as white and had kindergarten or less in terms of education. There were 0 for those who identified Asian. 0 for Hispanic. If we look at college graduates, for example, there were 15 in the Asian category, 15 in the American Indian Alaska Native category. So this is a contingency table that we're used to. Now we know that whenever we look at frequencies, we could also look at relative frequencies. And if you'll remember, there were two different types of relative frequencies that we could look at. We could look at what are called marginal proportions, or we could look at conditional proportions. And so we have a couple functions to help us do this. The first function is called margin.table. So margin.table is going to help us compute marginal proportions. And so to use this function, what we do is inside of the parentheses, we give the name of our table and then comma, either the number 1 or the number 2. Number 1 is going to give us the frequencies for our first variable. So notice here the first variable A was education. B is going to give us the frequencies for our part 2 is going to give us the frequencies for B. So let's run these and see what we get. So if we use this one, notice what this does is this is going to give me my frequencies for education. So just as a reminder, we actually already did this before. And what we did was we used table, and then we called the Kentucky data set, and then we called the education variable. So we did this back in Module 6. And so notice if I run this, we get the exact same counts. So we can see this is giving us the exact same information as when we just looked at education by itself. And the reason for this is it is summing over the other variable. So for example, to get the kindergarten or less, it's summing up this whole row. And that's how it's getting 4 here. To get the elementary, it's summing this row, and that's how it's getting the 209. Now, if we run the second version of this function, and notice now we've got a number 2 instead of a number 1, it's going to do the same thing, but create a table of race for us. So notice here, we see that we have 5,543 identified as white, and if we go back to our table, if we summed over this column right here, we would get that same value. So that's how you get the marginal proportions, or marginal frequencies in this case. I guess I should say frequencies, not proportions. And notice we could use these to get the marginal proportions similar to how we got marginal proportions earlier on in the course. To get the marginal proportions, we would need to divide by the total number of observations. Now, for the Kentucky data set, there are no missing values. But there might be missing values for yours. So in order to find that, or to know what values to divide by, we need to make sure that we find the number of observations for the two different variables. So we could have n obs for education. And if you'll remember from Module 6 to do this, we're going to find the total number of rows in our data set. And then we're going to subtract off the number of missing data points. And I'll include this with the file that you have on Canvas. And then we'll want to do the exact same thing for our race variable. So I'm going to call this number of observations race. And I'm going to do the same thing, except I want to call my race variable. So I run these. And so then to get my relative frequencies, or our proportions, what we do is divide by the corresponding total number of observations. So now we could run these. And so you'll notice here we have that relative frequency table of education, and we also have the relative frequency table of race. And if you go back and compare to the Module 6, this will be the exact same relative frequency table that we got before. Now we might also want to look at conditional proportions. So let's first look at let's look how to do that. And we're going to do this using what's called the prop.table function. So the first thing I'm going to do is call the prop.table function, and the only argument I'm going to give it is my table that I made earlier. So if we run this, what we have here, well, first of all, you'll notice that the table spans over 2 lines. So that makes it a little bit hard to read. So one thing you could do to make this easier to read is, if you'll remember, we used that significant digits function before. So let's do that just to make the table easier to read, and then we'll talk about what's included in that table. So I'm going to call the significant figure function. I'm going to give it the name of my table, and so notice the whole thing is going to be my table that I created, and then digits equal to 2. Again, just making it easier for us to read. Alright, so that made that a lot easier. So now let's talk about what the the prop.table function is actually giving us. So if we look through here at these different proportions, notice that some of these are zeros. Okay, so let's go back and look at our original frequency table, and I'm going to do it just by running this piece and see why that might be. Notice that there were 0 people who identified as Asian that had kindergarten or less. Same thing with American Indian, Alaska Native, and Hispanic and other. And so notice that corresponds to all of these zeros. Let's look at white in kindergarten or less. We had 2 in the column white with the row kindergarten or less. Now if I take 2 and I divide it by the total number of observations that we have in Kentucky, and remember that in total we have 6,604, this is the value that I get. So if we come up here, notice that that value rounds to this value right here. What if I take, in the white column, college graduate, 1,768, and I divide again by the 6,604. Here's the proportion that I get, and notice that that matches with this one right here. So what all of these proportions are is it is each of the frequencies from that this table, the contingency table, divided by the total number of observations. So what this tells me when I look at these proportions is I had about 27% of my overall sample were white college graduates. I can also see here in my sample that approximately 4% were black with some college, and almost 2.5% are black and college graduates. So using the prop.table and giving it our table tells us the percentages out of the total that we have. But often we're really interested in the conditional percentages. And so that's what these 2 tables are going to give us here. By having a 1, that's going to give us row percentages, and the 2 is going to give us column percentages. So now let's look at these. Alright, so looking here, if we look at the row percentages, what that means is we're going to look at the percentages of the different races for levels of education. So of those that had a kindergarten or less education, 50% were white and 50% were black. So let's go back to our frequency table to see where those values came from. So here's our frequency table. Notice in the kindergarten or less category, we had a total of 4 people. 2 of them were white and 2 of them were black. So this is why we get 50% here and 50% here when we look at the row percentages. Next, we could look at the column percentages. And this is going to do the exact same thing, but what it's going to do is condition on the different race categories. So here, if we condition on white, we see that about 30% are college graduates, almost 30% have some college, and about 30% are high school graduates. And if we go back to our frequency table, this makes sense. If we look at the column for white, we see that majority of the values are in these 3 cells. So that's where those are coming from. So these are different ways that you can create the contingency table, and once you create the contingency table based on frequencies, you then have to make the decision how you want to report the relative frequencies, how you want to calculate, and how you want to use them. Because depending on how you calculate them, they're going to tell you or inform you about different pieces of information. So let's now look at some bar charts. We're going to look at several different ones. And you'll notice for each of these I'm going to use that table that I created. So the first bar charts we're going to look at are bar charts with frequencies. So here I'm going to run this and we'll talk about it. So here's my bar chart. This is a stacked bar chart. And so you'll notice by giving this table in the function, remember that when we created this table, it was education by race. So what is going to happen is whatever the second one you give it, that's going to be what's along the x-axis. And then what you're looking at in terms of the different pieces that are stacked, that's going to be the first argument that you gave the table. So if you wanted to flip this so that you had education along the x-axis, and then race is what is depicted by, the stacking, what you would have to do is recreate this table right here. But when you recreate it all the way up here at the top, you would want to flip and call the race variable first and then the education variable. So that's how you can switch those. A couple things to notice here. We do have frequency along the y-axis. We know that we probably want relative frequency, so I'll show you how to do that in a moment. For colors, since education is what's being shown in the stacking, and education has 7 levels, that's why I have 1 through 7 here. So it's just going to use what it has labeled colors 1 through 7. If you have less than 7, if you had 5, for example, you'd want to use 1 through 5. You can also specify colors as well, similar to what we've done in the past. You can also create a side-by-side, and to do that, you just add in this argument at the bottom, which is beside equals true. And this is what this would look like. Now again, these are done looking at frequencies, but what we're really interested in are going to be some relative frequencies. So let's look at how we would do that. So the first one we could do is look at overall relative frequency. And so this is going to look at the proportions out of the overall total. And we could do this using a stacked bar plot. And so the only thing we need to change here is instead of calling our original table that we created, we call prop.table that function with our table inside of it. So similar to what we just did up above. So if we run this, what this is doing is this is giving us the relative frequency stacked out of the total. So you'll notice here if we look at the white column, white goes up to about 85%. Give or take, and what that tells me is 85% of my sample was white, and then I could look at the percentages within that fall into the different education categories. To make sure that we have all of our labels, just like before, we can stretch this out. And so we can tell by looking here that other Hispanic, American Indian, Alaska Native, and Asian are a very small piece of my sample, and it makes it very hard to see what's going on inside of these bars. So again, this is looking at relative frequency out of the total. We could do the same thing with a side-by-side, and we have this. Now what would be more interesting in these plots so that we can compare the distribution across the different races would be to look at the conditional. So if we condition on race. So let's see how to do that next. Notice here what I'm going to create the bar plot with is my table, but now I'm placing that 2 argument after it. So if we run this, we're going to get a different side-by-side plot. So this one looks different than the other one, and let's talk about why it's different. When we look at this side-by-side bar plot, again, our relative frequencies are computed out of the overall total. The second one is going to look at the relative frequency within each of the races. So what we're considering here is we're saying if a person is white, what is the relative frequency for each of these. So if you were to add up the total bar heights within a group, they will add to 100%. So if you add these heights, it's 100%, within black 100%, within Asian 100%, and so on. Whereas in this plot, since it was out of the overall total, if you added all of the bars over the entire graph, they would sum to 100%. A plot like this is very useful because what we can now do is, conditioning on race, we can look and see if the distribution for the different levels of education look similar. And so very quickly here we can see that if we condition on race, we see that a much higher percentage of those who are white are college graduates compared to those who are black. And then for those who are Asian, we have a much higher percentage that are college graduates. And so this allows us to look at that distribution within whatever variable we have here along the x-axis comparing to the other one. So these plots can be very useful and give a much clearer picture of what's happening than when we look at this one, which looks at the relative frequency out of the overall total. Now, one thing that you'll notice here is my legend is overlapping the plot. I'm going to show at the very end how to change that. The other type of stacked bar plot that can be really useful is what's called 100% stacked with relative frequencies, and this is what it looks like. So what this one does is the same thing as the side-by-side, but what it's doing is it's conditioning on race, and you'll notice for each race we go up to 100%. So what we see here in this stacked bar plot is similar to what we saw with the side-by-side that we just looked at, is as I look across, I can see that within race, the distribution of education does differ. And so that might suggest there's some kind of association. All right, so the last thing I want to show you is how to move that legend. So there are more sophisticated ways to plot in R, but in order to try to make this as simple as I can for you, I'm going to show you kind of a way that you can change this by brute force, and you just have to play around with it. So the first thing we're going to do is make the margins bigger. So the margin is the space that goes around the plot, and the only piece you'll need to change is this piece right here. Now what these four numbers represent is this is bottom, right, bottom, left, top, and right. So this last number is really the number that you're going to want to change, and what it's going to do is it's going to make this margin over here on the right bigger. Next, I've got the same code that I have above, except I have added in this last line. The only piece you need to change in this last line is this number right here, which is called the inset. And what it does is it looks at a proportion of the plot and decides where to place the legend. So let me run this. So using the numbers that I have here, here is what it does with my legend. Now you'll notice my legend does overlap my bars, but you know, it's readable now. I can see what's going on. It's not covering things up. For yours, you probably won't be able to use the exact same numbers. I'm so sorry if you can hear my dog barking. You probably won't be able to use the exact same numbers, but what you can do is just kind of play around with these numbers, and what you'll see when you run this is that legend's going to move some, and so just tweak those numbers a little bit until you get the legend in a good enough place that it's readable and it's not covering up your plot. Alright, last thing here, we're going to look at some scatter plots and some of the regression stuff that we saw. Here we're going to look at the height and the weight variables for the Kentucky data set. As always, we're going to start by finding the number of missing values, and we'll want to document those. And so if you wanted to, here in the comments, you could just add in a comment that has, you know, how many missing values we have. So we had 144 missing values, and for weight, we had 359 missing values. And then the next thing we might want to do, just to make it easier to work with, is we might want to rename them. To rename them, what I've done here, and we've seen something similar to this before, is I'm just going to set height equal to, I've got the name of my data set, the name of the variable, weight equal to, name of my data set, and then my variable. So we can run these. And then next, we might want to get a summary of these two variables. So running the summary function, notice this is going to give me the mean, the median, the max, and it also gives me the number of missing as well, so I could get it that way. To create a scatter plot, we use what's called the plot function. We give it the x and then the y variable. And so the first line here is the most basic scatter plot that we could get. But as always, we might want to make the plot a little better. So PCH, that's going to change the type of point that's in the plot. Main is going to give us a title, and then we might want better labels on our axes. So there's a little bit better looking scatter plot. And then finally, we might want to add in that regression line that we saw. So the first thing we would want to do is figure out what the correlation between height and weight is. And we need to give this use complete observations because we do have some missing data. So we see that the correlation between these two is about 4.7. And then to fit the model, what we do is I'm going to name this simple linear model. So this is a name that I chose. And then I'm going to use the LM function. So we are looking at weight, which is the y variable, as a function of height. So for yours, you'll just put in the two names of your variables. Make sure that you have them in the correct order. So you want y and then x. This creates this object which stores the regression information. So we could look at a summary, and this will summarize. We can see here we get our intercept and our slope. And using the add line function, we can add the line to our scatter plot. And then finally, to find and plot the residuals, we can call the object that we just created, $, residuals, and look at that histogram. And so there we can look at our residuals to help us check any assumptions. So one thing when working with a regression line is we want to make sure that, if we have any outliers, we document that. We also need to look and see if our residuals are approximately normal. That's what we call an assumption of regression. And so if you take a course past this, they'll talk a lot about what the assumptions for regression are. But one of the important ones to notice is that we want to make sure that our residuals are approximately normal. And we can see that this is an approximately normal curve. But again, if you take a further course in regression, you'll learn more about the assumptions and why the assumptions are important, because it's whether or not we can rely on the output that we find. So this is going to end the Module 9 video. Of course, if you have any questions or need help, please let me know.